Welcome friends, welcome to iLitmus Study Chemistry Online. Today we are going to study our second chapter, which is acid, bases and salt. Still we are remaining with 3 more chapters. So let's start today, acid, base and salts. So what are the topics under that which we are going to discuss? Understanding the chemical properties of acid and bases. Then acid and base in laboratory, how we'll try to understand a little bit more about that. Then reaction of acid and base with metals, acid reaction with metal carbonates and hydrogen carbonates, then reaction of acid and base with each other, reaction of acid with metallic oxides, then non-metal oxides with base, what is common between all acids and all base, mixing acid or base in water, then what it happens, then how we measure the we call it like acidity and basicity of acids and base, so how the strength is measured, then importance of pH in everyday life, and then we'll study more about salts, like family of salts, then pH of salts, chemicals from common salt which is called as sodium chloride. Are the crystals of salts really dry? Yeah, so let's go forward. So understand the chemical properties of acid and bases. Okay, so acids, the words are very important, okay, which you can write in your exams. So what are acids? Chemical substances which aqueous solution, when you will mix with water, then solution is sour, okay, it turns the blue litmus red, okay, methyl orange to red, okay, phenolphthalein which is colorless in acid, okay, so when phenolphthalein will come in the contact of acid, it becomes colorless, and pH of acids is always less than 7. What is base? It tastes bitter, turn red litmus blue, so you can understand this difference. Yeah, okay, if litmus is converting from red to blue, means it's a base, pH greater than 7, while feel it like it's a soapy feel you will get if you are touching a base, then it turns phenolphthalein to pink and methyl orange to yellow. Okay, so these are very important. Most cases you will get some question on this. Yeah, so this is the typical representation. If this side methyl orange becomes red, so this is neutral, which is pH 7. Below this one, which is the property of acid. Yeah, for different indicators, methyl orange, methyl red, bromethylene, then phenolphthalein. Yeah, so you need to know more about this phenolphthalein, litmus, which is this litmus, and methyl orange. These are the 3 important things for us. Okay, so you can see litmus becomes red by acid and blue by bases. Phenolphthalein colorless in acid but in pink into base. Methyl orange red into base acid and yellow into bases. Then reaction of acid and base with metals. What happens? Zinc is a metal, H2SO4 is a strong acid. Yeah, so what happens? It makes zinc sulfate plus hydrogen gas comes out. In labs, how we can test it? When the gas which is coming out, if you put the flame, then flame it gives like burning flame. Yeah, so you can understand it's hydrogen oxide and hydrogen. Okay, so most of your metals when interact with chemically reacts with strong acids, it make their related salt and hydrogen gas comes out. This is a typical representation of the laboratory experiment. Sorry, where this is the acid, inside that the metals granulars has been put into that, and a little bit heat if you will give, after then you will see the hydrogen gas is coming out, and burning hydrogen, it has a property of hydrogen, If you put near candle, it will burn. Yeah. So above reaction with sodium hydroxide, which is base, what will happen? Again, hydrogen gas comes out. Okay. But this is very important that, but as you going down periodic table, okay, metals will not react in the same fashion due to less reactivity of metals. Okay, so as you'll be up in the periodic table, they'll be having more reactivity towards acid or bases. Okay, so acid reaction with metal carbonates and hydrogen carbonates. So again, a typical setup has been given in that here is like sodium carbonate, yeah, and this is hydrogen chloride inside the test tube. Then it is warm. Then from here you can see the calcium carbon dioxide coming out. How you go and test this is a carbon dioxide. When you pass into a calcium hydroxide solution, it forms calcium carbonate, which is precipitated in that tube. So in this way you can know that this is a carbon dioxide gas coming out. Okay, so this is what has been shown that if you are putting sodium carbonate with HCl, then it's making 2NaCl, which is our common salt, and then H2O plus CO2 gas, which is coming out. So as I told, CO2 gas passed out into calcium hydroxide, and calcium carbonate is formed. Okay. Same equation is the bicarbonates. Okay, so what we get it from there, if acids will react with metal carbonates or hydrogen carbonates, again their related salt will be made, and carbon dioxide will come out if it contains carbonates. Then reaction of acid base, what it happens, this is very critical to understand, yeah, going forward. So bases plus 8 always makes salt plus water. Okay, if taken in equal equivalent amount, then product will be neutral. Okay, why I am saying equivalent, maybe in further we'll explain this very clearly. We can say, for example, if you are taking more equivalent of base and less equivalent of acid, so in the particular solution which is coming out, salt plus water, there is a chance that the base will be remaining. Okay, so pH may not be neutral. But when you are taking the equivalent amount, then as we know that equivalent number of always like equivalent amount of base and equivalent acid will always go and make the same number equivalent of salt and water. Okay, so whole your base and acid will be consumed. So salt and water doesn't have any pH, it will be pH of 7. Sodium hydroxide and HCl, this is a typical example which is given. Reaction of metal oxides and acids. Okay, so remember that here that can be cases of like strong acid. This is the strong acid and strong base, but when we can have a strong acid and weak base, then again it makes form salts, but the product which will be coming out, the mixture, the solution which will be remaining in the product, that may not have the pH of 7. That will be based on what was the stronger. If the acid was stronger, then pH will be lesser than 7. If the base was stronger, then pH will be greater than 7. Sorry. Reaction of metal oxides with acids. So what will be? It again forms salt plus water. Example, Fe2O3 plus 6HCl, FeCl3 plus 3H2O. Okay, so metal oxides again behaving like bases. Okay, so again it is acting like a base plus acid reaction which is forming salt and water. So metal oxides are basic in nature. Reaction of non-metal oxides, CO2 and CaOH twice, calcium carbonate plus H2O. Okay, so CO2 is non-metallic oxide and CaOH twice is base. It's forming a calcium carbonate which is again a nucleic salt, then H2O. Means non-metallic oxides are acidic in nature. Okay, if CO2, then CO2 will be acidic. because it's again forming a salt. So if base is forming a salt with someone, it means that that reactant is having acidic in nature. What's common between all acids? Every acid has H plus ions, okay? Because acid is always defined by having H plus ions into that. If H plus ion is not there, it cannot be an acid, okay? Similarly, every base has OH minus ions, okay? Mixing acid with water, what happens? When you mix acid mix with water, then H plus ions it get ionized, okay? So say you are putting HCl into water, so H plus and Cl plus ions come out into that, okay? It becomes ionized. So remember, the H cannot exist alone, so they bond with H2O molecules and make hydronium ions. Yeah, generally H plus are very reactive, so they form bonding with H2O molecules and create that. For your information, even H2O normal water also it dissociates, but at the same time it H plus and OH plus created, OH minus created, but then and again it forms H2O molecule. Okay. So dissociation and association happens at the both rates. Mixing bases with water generates OH minus ions. Okay, again it's a again ion. So when acid or base is dissolved in water, then it dissociates to H plus ion and OH minus ion. Okay, but H plus ion and OH minus are very reactive and they form water. So what remains, that is becomes salt. This point remember that strong acid dissociates completely, but weak acid doesn't dissociate completely. So if you're putting a strong acid, you'll be having 100% dissociation, but if you're putting a weak acid, so it may not furnish you 100% H plus ion. Bases which are soluble in carbon alkalis. This is a typical example where hydrochloric acid, which is H plus and Cl minus, put into water, so it become like ionized. It be having Cl plus ion and H plus ion. Then for your bases, you have sodium hydroxide here. When you put into aqueous, then it becomes Na plus and OH minus ions. And as you know that H plus and ion, they mix it up and they form water. Strength of acid or base solution, how it is measured? Okay, so pH is one of the like criteria to measure acids or basic solutions. Okay, so pH is function of concentration of hydronium ion. Okay, we always take the concentration of H plus ions, not OH minus ion. Okay, so acidic nature, when your pH 7 is neutral, if it is lesser and as you are leading towards 0, you will be having a very strong acid. If you are going towards 14, then it will be having a strong base. So as you are going towards 14 means decreasing H plus ions. You are increasing here, increasing H plus ions. So measurement of pH is always based on H plus ion concentration, not OH minus. Yeah. For more calculations, we will be having coming chapters where we will be defining how to define the pH, how to calculate the pH. Yeah. Strength of acid is measured by ability to produce hydrogen ions. So same amount of strong acid will produce more hydrogen ion than weak acid. Okay, because of the H plus concentration. So a strong acid H2SO4 like that is an acid that ionized completely in an aqueous solution by losing one proton. H plus is nothing but one proton. As you know that hydrogen doesn't contains any neutron. So HA is a aqua, HA is a typical acid, so H plus aqua and A minus aqua. For sulfuric acid, which is diprotic, the strong acid designation refers only to dissociation of the first proton. Okay, so H2SO4, H plus and HS4 minus. Okay, this will be representation of dissociation of sulfuric acid, not that both the H plus has to come out. The strength of base is measured by ability to produce OH minus ions. Importance of pH in everyday life. pH, actually we don't know in terms of pH, but we always like go through these importances. We know all this stuff, just it has been mentioned how the role of pH into that. So are plants and animal pH sensitive? Yes. Sometime you have heard that because of acid rains, the water in the river or in the lake becomes very acidic, and the fishes or other water related animals living in that, they die. Okay, so generally plants and elements, their life is having a very limited pH range in which they used to live. Okay, if pH is increasing or decreasing, it will be having a huge repercussion on their existence. pH of soil in farmland. Have you heard that nowadays agriculture is becoming technical? So what the technical? They guys go take your soil, they understand it is basic or acidic, and accordingly they suggest what kind of cropping you need to do. Okay. Then pH in our digestive system. In our inside, hydrochloric acid is generated by our body in our digestive system. Okay, so once sometime you have heard that someone has become अरे उनके पेट में एसिड हो गया, अरे तो उसके लिए दे पीपल यूज टू गिव सम बेकिंग सोडा उनको घोल कर पिला देते हैं, या फिर एंटा एसिड जो टैबलेट आते हैं, एंटा एसिड टिपिकल बेसिस. सो यदि ज़्यादा एसिड हो गया तो हमारे डाइजेस्टिव सिस्टम में वी पुट सम बेस, इट गोज एंड न्यूट्रलाइजेस दैट एक्स्ट्रा एसिड. ओके, so pH has a huge role into our digestive system. pH in tooth decay. Generally in our mouth, whatever the decay, how it happens, some food or some sugary content is there, so that is broken, and acidity increases in our mouth. Okay, so acidity, mouth becomes acidic. It is a huge problem, and this is the real thing behind our tooth decay. Okay, so this is a very important thing to how to understand that. So if you're cleaning your mouth, generally the toothpaste which comes, it is a basic in nature. Okay, so that is used for cleaning those parts. Actually we don't clean the virus inside it, we clean the food or any other sugar content in our tooth. Okay, and we try to maintain the pH inside our mouth. Self defense by animal. Have you seen your bees, how they when they will be stinging, you will feel very jittery. Okay, so those contain some acid. A typical natural source, and what kind of acid? Vinegar, orange acid, citric acid, turmeric. So all this you can see that. Okay, so there are natural resources where you find different kind of acids. Salts, again we know that strong acid, strong salt, pH 7, strong acid then less than 7, strong base means greater than 7. Okay. Chemicals from common salt. Sodium chloride is called as common salt, which you find in ample into sea water. Okay, so what is the use of that? So if this sodium chloride, if aqueous sodium chloride, if you put an electricity is passed into that, then sodium hydroxide, you can sodium and chlorine and hydrogen gas comes out. And for your importance, sodium hydroxide is a very important base which is used in several reactions and all. Chlorine is a very important gas which is used for cleaning because it has a ability to kill germs. So chlorine is used. Chlorine is again used for several other purposes, like in making of bleaching powder. If you pass chlorine into calcium hydroxide, it makes CaOCl2 called as bleaching powder. The actual bleaching powder has a different complex composition, but understand that this is a combination for that. Okay, so with our existing common salt, we used to create multiple different salts of very importance. Then baking soda, how you make is sodium chloride plus you pass the carbon dioxide and ammonia NH3 into that, it makes NH3 because NH3, it's a baking soda. Okay, baking soda, you know that it is used in our houses for making some kind of like bread and bhatura. Okay, so how it is made? If you'll heat NaHCO3, what happens? It creates carbon dioxide into our food, which makes the food very spongy. Suddenly, all the spongy foods are always sodium NaHCO3 is used, which is called as baking soda. Washing soda, when sodium carbonate 10H2O is there, again it's a crystal. Okay, we'll understand crystals separately, but when you say crystal means some water molecules in specific defined numbers, they are attached to that salt and they act as a crystal. Okay, so are these crystal salts really dry? No, not at all. If you will heat a normal washing soda, it will, some vapor will come out of that. Similarly, जो elements होते हैं फिटकरी, if you will heat into that, water will come out of that. Yeah. So water of crystallization is fixed number of H2 molecules present in salt formula. Yeah. एक major example is our washing powder. We'll see another very important example which everyone almost have seen. Plaster of Paris. What is that? Is obtained by heating gypsum, which is called calcium sulfate, with 2H2O molecule attached. When it is heated, okay, at around 373 Kelvin, then it converts into a powder, which is called calcium sulfate half H2O. Okay, which is called plaster of Paris. So ये क्या होता है? ये पाउडर टाइप का होता है. हाँ, तो जिसका हाथ वह टूटता है तो हाथ को सीधा करके, हाँ, और उसके ऊपर इसी का जो मिक्सचर होता है प्लास्टर पे, इसका वाटर के साथ मिक्सचर के साथ उसको पानी के साथ मिला के एक लेप टाइप का उस पर लगा दिया जाता है. ओके, सो उसके क्या होता है, उसके बाद जब थोड़ा सूख जाता है तो अपने आप इट कन्वर्ट्स इनटू जिप्सम, क्योंकि कैल्शियम सल्फेट हाफ H2O, इसमें आपने पानी और मिला दिया, इट बिकम्स जिप्सम. ओके, सो जो कि बहुत हार्ड होता है. ठीक है, इसका यूज होता है, डॉक्टर लोग इसको यूज़ करते हैं. तो ओके, सो देर आर सो मेनी लाइक salts which are very useful in our common lives in industrial purposes. Okay, so this is all about your this chapter. Thank you very much. Thanks for watching this video. Again we will come with our third chapter. You can watch all our previous videos on YouTube. Thanks for watching.